George, I think you hit the nail on the head with the isolated interacting elements effect with your example. For my math class, I really saw how we use the guidance fading effect. But as I was reading through, I was trying to figure out where do we see the imagination. Is that what it's called? Yeah, the imagination effect. And I realized that I use that a heck of a lot more than I thought I did. When teaching concepts, I often will draw pictures, or I'll just sit back and ask questions and try to get them to think about solutions before I even show them how to do it. But the book actually said that the only way that a student can imagine a solution is if they have a really good foundation of expertise. And I just taught complex numbers, and having to understand why I squared comes out as a -1, I didn't realize that really is, since it's all imaginary numbers, they really have to have a good thought process of what it means to pull out a negative or an I out of a square root. And I only have 7 students this semester. Only 1 student was able to explain why I squared was equal to -1, and how all the squares could be reduced to either I, -I, 1 or -1, which goes right along with the text. And even simple ones like the taking the area formula of a triangle and just looking at the fact that 2 squares make up a triangle, or a rectangle makes up 2 triangles, and trying to get them to imagine the area formula based off of what they already know is pretty hard for my students because they don't have much of a background. And I think I was teaching as, come on guys, this is really easy, like just think about it. And I think it gave it a little bit new perspective, that because my students are so remedial that they don't have that background, so they can't imagine solutions because there's nothing in there. So anyways, thanks so much for your post and for listening. Bye.